Okay, welcome to week 7 video 6 exceptions. First part of it anyway. Right, as the slide says, sometimes things go wrong. And in fact, a large part of programming often is trying to deal with the things that go wrong. The things that go right are the easy bits. So, exceptions are, as the slide says, unexpected happenings. So the sort of things that can go wrong. You try to read a file, there's no such file. You try to read the file and it's corrupt. Or you're trying to read the data off a network and the network's not up, fails in some way. Or you're halfway through an important file system update and the user is getting bored and they type Control-C or something to kill the job, and you can't let that job get killed until it's finished cleaning up the files. Or you've made a mistake yourself. You've divided by 0, subscript error. I'm sure you've all made those mistakes. And the most common thing of all is the user enters bad data, and you have to program defensively to prevent that. So all of these things, you know they might happen. You don't know exactly when they'll happen. And so the problem we're going to deal with in this slide is how do we defend ourselves against such things? I say this slide, this whole video, and the next one as well. So, in the old days, I'm talking about languages like C, we didn't have any built-in mechanism in the language for dealing with problems like this. So every function that you wrote, if something could fail, you had to define the return value in some way so that if the function worked correctly, it would return this, otherwise it would return some other bad special case value. And there's still a little bit of that around. If, for example, I come down here in Python and I say S is the string Fred, and I want to find the first occurrence of X in Fred, which obviously doesn't exist, there's a method called find, and I can go s.find, in that string Fred, try and find the first occurrence of X. And I get the value -1, which is an illegal index. So that's a special case value that tells me that the find failed. So that's the error condition, and if it works correctly, if I try and find the character R, then instead I get back the actual index. So that was how you had to program all the time. So programmers were always writing stuff like index equals s.find x, and then if the index is equal to -1, then they would do something like some error handling condition. Otherwise, they would go ahead and do the right stuff. So this was the good stuff. But programmers, being what they are, humans mainly, optimistic, my code couldn't possibly fail, this is never going to occur. So they just tended to assume that the index value was correct and just do the good stuff, and the programs crashed. Surprise, surprise. So that's what this bit says. Programmers are lazy, they tend not to bother, and programs crash badly. So a lot of traditional C code was very fragile if you gave it bad data. In Python, there is actually another way altogether of looking for a substring inside a string. If you're pretty sure it's there, you can go s.index of R, whoops, that's an error, s.index of R, and what you get back is 1. And if you look for something that's not there, then instead of getting the value -1, you get an error message of some sort. This is called an exception, and that's what we're going to talk about. So let's sort of replicate that piece of code over there in the next slide. So I'm going to write a function print reciprocal. Because I'm a well-trained programmer, I write a nice docstring, not ASDF, prints the reciprocal of n. And so what it's going to do is calculate reciprocal, which of course is 1 over the number n, and then it's going to print the value of the reciprocal. Oops, reciprocal of, I'll write it using a format statement. Reciprocal of this is that, where this is n and the reciprocal is indeed the reciprocal. And now let's just test it. I'll go call the print reciprocal method with a value of 3, and we'll just prove that my code works beautifully. It evaluates it and says the reciprocal is 0.3333, etc. However, what if either I make a mistake or I've given this code to somebody else and they make a mistake, and we call print reciprocal with a value of 0. Then we get this business again. This is a traceback. It's the result of a program crashing due to an exception occurring. Now, often I don't want to get an exception occur. I don't want it to crash. I want to keep the program going and say, hey, you can't give me a 0. Try again. That was a bad call. So generally, you want your programs not to fall over with Windows has encountered a problem and will restart sort of error messages. So the way you do that is you catch the exception. So what I do instead, if there's a piece of code I don't trust, I try executing the piece of code. That's what that means. And because it's ends in a colon, we have to indent the block after it. Try, and I have this special piece of syntax to say, except if something goes wrong, I'm going to print instead that something or other does not have a reciprocal where the something or other is in. Right, see what I've done? I've got the piece of code I know might crash. I've put it in a try except block. So now when I run it, it says, thingy does not have a reciprocal. Maybe if I'd given it a format, it would have helped. Sorry, try that. Now it says 0 does not have a reciprocal. And this is kind of flexible because I can also say, you could press a check to see if n is 0, but that wouldn't suffice because what if I called reciprocal with the string 4? I want to know the reciprocal of 4, and again it says 4 does not have a reciprocal. And you might think, oh, well, I'll put in a check for that as well. But then they call it with a list. Lists don't have reciprocals. And there's just so many different cases, you can't deal with them all with if statements. So the way to deal with them is with this generic exception handling mechanism. Something I should have warned you about is that this code as it stands is not Pylint compliant. In the next video we'll talk about how to make it Pylint compliant. But for now, this is the principles this slide will do. So just to explain what happens, we've got the suspect piece of code here, the normal, sorry, I call it suspect. This is the piece of code that I suspect may possibly fail. And I've got an exception handler for it here. Now, actually, to be more specific, the only bit I suspect may fail is that. I know that bit won't fail. So I can actually use a slightly different syntax, although I must admit I don't tend to bother doing this, but you should know about it. What you can do instead is this syntax. You can try that, except if something goes wrong, you do that, and if everything goes normally, you do that. So that piece of code behaves exactly the same. So I've got try doing that. If you get an exception, do that. Otherwise, if everything's gone according to plan, you print the reciprocal message. And so that, as this piece of code says, allows us to separate the normal code, that's what normally happens, from the exceptional code there. So as it says, risky codes is inside the try block, and if the exception occurs, then Python engine tries to find the first handler it can find. We'll explain that in a bit more detail in the next video. So this last slide just summarizes the situations in which you need to use this sort of construct, the try, except, and an optional else. Most commonly, the reason you use it is to protect yourself against bad user data. Often you've been taught to write things like the age is equal to the integer value of the result of calling the input function with some prompt. But that might fail. A student might enter a piece of text, they might enter 18.5, 18.5, and that won't convert. You wish to be able to give them a prompt to say, no, sorry, that's not a valid input. You don't want the program to crash. And similarly, when you're processing data files, you often need to, or almost always need to deal with the possibility that the data is bad within the files. I've mentioned system errors, network errors, things like that. And lastly, there's a quite common situation where it's very hard to write a program to check some things, such as whether a floating point or a particular string is a valid representation of a floating point number. You may think that's easy, but trust me, you give it a go. See how many if statements you need in order to be able to accept all of these things here, but not that one, for example. It's difficult. So Python programmers often make use of try, catch, in a simple way. Sorry, try except as a solution to such problems. You just try converting it, and if it doesn't work, then it was invalid. Simple as that. Thanks for watching. See you in the next video. Bye.